Hello everyone, thanks for tuning in. I wanted to have this last minute virtual lesson for you guys because I've been getting a lot of questions about problem 93 in the review. So we're just going to take some time to go through it and see if I can answer any of the questions that you guys seem to be having. One thing I will say is this problem is a little bit tricky and might be a little more difficult than what you're going to see on tomorrow's quiz. But I think what you'll find is actually it is very simple. It's just maybe not a problem that we've seen worded this way before. So on July 19th, 1969, Apollo 11 was adjusted to orbit the moon at a height of 111 kilometers. The moon's radius is 1,738 kilometers and its mass is 7.3 times 10 to the 22 kilograms. They are asking us for the period of Apollo 11 in minutes, and then the velocity of the craft while it was in orbit. Okay, so the first thing that people really seem to be having an issue with, in both of these problems, we need basically three things. We need G, which is our gravitational constant. We know the answer to that. Okay? The other thing we need is the mass of the craft. Usually it's the mass of the Earth, but in this case it's the mass of the moon. Okay, so I'm just going to put M. Kilograms. Okay. The other thing that we're usually looking for in our problem is our R value. Okay? And I think some of you got a little confused because we see that it's at a height of 111 kilometers, and then it gives us the moon's radius. Okay, so not really sure what to put for R. Let me draw a quick picture, and I think this will help you. Here's a picture of the moon. Very nice. Okay, Apollo 11 is somewhere floating around the moon. Okay? It's orbiting around the moon. So the height that they're talking about here, this height of 111 kilometers, is here to here. Okay? So they're talking about the height from the surface of the moon. Okay, that's how far that craft is. When they say the moon's radius is 1,738, they're saying from the center of the moon to here, this is 1,738. Okay? So, if R is the value from here to the center, R is going to be 1738 plus 111 kilometers. Okay? So then in turn, our R value is going to be equal to 1,849 kilometers. Okay? Now, I can go ahead and put this down here, but remember from some of our other examples that we've done, our R value actually has to be in meters in order for our equation to work. Okay? So R is going to be equal to this number, 1,849 kilometers, but we know there's 1,000 meters in a kilometer. So R is actually equal to 1,849,000 meters. Okay, so we're just taking this number in kilometers, we need to turn it to meters or our equation's not going to work. Okay, so this is what we need to write right over here. 1,849,000 meters. Okay? the distance from the center of the moon to the center of the satellite. In this case, it's Apollo 11. Okay? So that was one of the first things here. And I think once you get that R value, I think a lot of you are going to be home free. Okay? For the period equation, right, remember, equal to 2 pi times, I don't want to mess this up, 2 pi times, that's right, yep, the square root of r cubed g times the mass of the Earth, but in this case it's the moon, so we'll just call it the mass, okay? So we substitute our r value in here, our g value here, the mass of the moon in here. Make sure that you are typing this into your calculator correctly, okay? So I would recommend that you learn how to use your parentheses and learn how to kind of type everything out so that your order of operations is correct. What you can do, though, is you can kind of break it up into some smaller equations. Take your r value, cube it, okay? Divide that by parenthesis g times m parenthesis, okay? Take the square root of that number, multiply it by 2, you guys get it. And so make sure, though, that you're incorporating each one of these features in your equation, or you might run into some trouble. And you're going to want to do some practice for that for the quiz tomorrow. Okay. And our V equation, I'm just going to draw this out. It's kind of the same message. Okay. So again, make sure you're including that square root in there. Make sure you're properly multiplying g times m and then dividing everything by r before taking that square root. In this equation, this is going to give us an answer in meters per second. Okay? Probably what unit I'll ask you for on the quiz, so you don't have to mess around with it. In our period equation, I didn't mention this before, our period equation is going to give us an answer in seconds. Okay, so like we saw in one of the videos on period, we want to, if we have an answer of 60 seconds, all right, and we want it in minutes like they're asking for here, we just take that answer, divide it by 60, and we're left with 1 minute. Okay, so that's not the answer to this, but when you get your answer for the period equation, it's going to be in seconds. If it's asking you for minutes or for hours or even for days, make sure you're making the appropriate conversions, okay? Dimensional analysis isn't exactly required for this because it's pretty simple, but you may find it helpful, okay? Otherwise, please feel free to email me with any questions or set some questions up on the Google Doc. Good luck, guys.